These programs are distributed under a Creative Commons Attribution, Non-Commercial, No Derivatives license. You may copy and distribute these programs free of charge. You may not sell them, and you may not alter them. These programs are part of a study examining the value of podcasting as a medium for medical education. If this is the first time you are viewing a program in this optic series, send an email to jyoungmd@gmail.com with your name, position, institution, and city, state or province, and country. Thanks, and enjoy the podcasts. Today's lecture follows the conversation about anisometropic anisophoria with Prentice rule. And it is once more a set of prism problems that we run into in a clinic when we prescribe bifocals for patients. This is a photograph of my wedding. It was a lovely wedding. There are several things that I want to point out in this photo. The first thing is that the spectacle through which we are viewing this photo is a myopic spectacle, and I can tell that because there's some degree of minification of the image throughout the distance portion of the spectacle. So if we look at this portion over here, we see that there's some minification going. Then there are two things that we notice in the bifocal segment. One of the things is that there's a discontinuity of the image at the superior edge of the bifocal, right at this interface here. There's a discontinuity of the image where the image is seen to jump, and we creatively call this image jump. Image jump is annoying and something about which patients might complain, but is not going to be a factor that we are going to consider very much when we prescribe bifocals, and I will show you why. The image over the entire span of the bifocal segment is to some degree displaced, and we refer to this as image displacement. And I want you to notice something, that in this photograph there are 5 stairs. 1, 2, 3, 4, 5. And indeed, at the wedding there were 5 stairs, and that is important because we're going to look at the next picture here, which is an alternative setup in which we have the same myopic spectacle, but we have a bifocal segment that rather than being flat on the top is rounded on the top. And there are two things that we notice. One is that there's a lot of discontinuity of the image at its superior edge, and this is image jump, and that is annoying to patients. But more importantly, if you look at the bottom of the view through the spectacle, we see that only 3 steps are observed. And this is problematic because we know that there are 5 steps, and the patient wearing these spectacles is likely to trip. So although the image discontinuity, the image jump at the top of the bifocal segment is something that can bother patients, image displacement, the displacement of the image over the entire bifocal segment, is something that can make patients trip on stairs. And it is with the consideration of minimizing image displacement that we prescribe the particular sort of spectacles that we're going to prescribe. Let's talk about bifocal types. And I'm going to present a few types here, actually 3 types, that we'll be talking about. So let's first of all think of bifocals as ads as being a lens that's as if it were glued onto the front surface of the patient's distance spectacle. So the question is, what are we going to glue on there? Well, we're going to start out with a plus lens. All ads are plus lenses. All bifocal segments add more plus to the distance prescription. And we're going to start out with the idea of a +3 lens. And we see the +3 lens in the left part of this slide drawn en face, as if we're looking right at it, and then drawn in profile. And as we discussed when we were talking about Prentice rule, we can approximate the shape of the profile of a plus lens by the shape of 2 prisms oriented base to base. Because that arrangement, like the plus lens, is thicker in the center and thinner as we get towards the edges. What we're going to start doing now is we're going to start to slice this lens up. So we're going to take the bifocal segment here, our bifocal lens here, our ad, and we're going to cut it in half, and we're going to discard the bottom half of the lens. And what we're left with is part of a lens. It's still plus 3 power. That is round on top, and we're going to refer to this not originally as a round top bifocal. And we notice that the round top bifocal is as if it were a prism oriented base down, because it's thicker at the bottom and thinner at the top. Now, we remember from Prentice rule that the amount of prism that is induced is equal to h times d, where h is the distance in centimeters from the optical center of the lens and d is the dioptric power of the lens. Image jump, which occurs exclusively at the superior interface of the bifocal segment, is a result of the sudden introduction of prism at the top of the bifocal segment, sort of the discontinuous introduction of prism right here. So the question is, how much prism is induced at the top of a round top bifocal segment? Well, with all of the bifocal segments, all the ads that we're going to be dealing with, they're all going to be plus 3 power. So d in the h times d part of the Prentice rule formula is going to be constant. What's going to vary is h. So the question is, how far are we from the optical center of this lens when we're looking at the top of this ad, at the top of the round top bifocal segment? And the answer is that h is at its maximum. It's as far as we can possibly be from the center of this lens. So round top bifocals introduce a lot of image jump, a lot of discontinuity at the top of the bifocal segment. Now note, I am not saying that round tops introduce a lot of image jump when applied to a plus lens or a minus lens or an astigmatic lens. It doesn't matter. In all contexts, round top bifocals create a lot of image jump, a lot of image discontinuity at the top of the bifocal segment. Now recall again, we are not going to prescribe the ad type by the amount of image jump that's induced, but by the amount of image displacement. We'll be talking about that shortly. A flat top bifocal is created when the lens is sectioned just inferiorly to its optical center. So h here is not 0. We're not at the exact optical center of this lens at the top of the bifocal segment, but we're mighty close to it. We're certainly a great deal closer to it than we were in the case of the round top bifocal. So h is a non-zero number, but it's a very small one. So the amount of image jump that is induced at the top of a flat top bifocal is not 0, but it is very small. You'll note, in contrast to the round top bifocal, which was a prism-oriented base down, the flat top bifocal is a prism-oriented base up. The other sort of bifocal that we're going to talk about, we'll talk about briefly now, is the Ben Franklin or executive type of bifocal. And this one is different from the flat top and the round top because these are not ads that are appended to the front of the distant spectacle. What is done is that the distant spectacle is cut in half and the lower half is discarded. And the reading spectacle, okay, not the ad, but the full reading power, whatever that is also cut, this time through its optical center. And the distance lens is glued to the reading lens. And we can distinguish this type of bifocal. You can see this clearly when patients come into clinic, because these are the bifocals that have the line that go clear across the frame, that the line that separates the reading portion from the distance portion completely bisects the lens. Now, since the lens is cut through its optical center, h here really is 0. So these are lenses that do not have image jump. And we do not talk about image displacement with an executive type lens. But we do talk about image displacement with the round top and the flat top lenses. So let's do that now. Let's say that this is a +5 hyperopic patient. That's to say that he's wearing +5 lenses in order to see at distance. And we're going to append to that an ad, and it's going to be a round top ad or it's going to be a flat top ad. So let's first deal with the case of the round top ad. The round top ad is a prism-oriented base down. You'll recall that from a previous slide. And the patient's own spectacles, since he's hyperopic, the lower half of the spectacles are prism-oriented base up. So the add that we're putting onto this is a prism of opposite orientation to the patient's own distant spectacles. Therefore, the two prisms will counteract each other to some extent, and the total prismatic power at the bottom of this lens will be reduced because we're adding a base down bifocal segment to a base up distance segment. Now, base up and base down equals less prism overall. If we were, let's say in the previous case, the patient with the round top here, I'll go back one slide. The patient with the round top bifocal, for whom we have minimized image displacement by setting up this arrangement of prisms of opposite orientation, comes back to your office complaining of image jump that he really does not like. A lot of discontinuity of image at the top of the lens. Of course, we know this is true for all round top bifocal segments, regardless of the distance lens to which they are stuck. And he says, I really want a lot less image jump, a lot less discontinuity. So we try to be smart, and we prescribe a flat top bifocal for him, because that creates less image jump. But what have we done in terms of prisms? The flat top add is a base up prism, and the bottom of the patient's own spectacles are a base up prism. So we've added a base up prism to another base up prism. We've compounded the issue of image displacement on the bottom of his spectacles. So although he may have less discontinuity of the image at the top of the bifocal segment, he's going to break his hip when he trips on the steps. So this is not an arrangement that is advisable. The myopic patient is lucky both ways. If we were to give this patient a round top bifocal, which, to say it for the umpteenth time, is a bifocal segment that has maximal image jump regardless of to what lens it is appended, if we were to put a round top bifocal add on the myopic patient's spectacles, we're doing him a double disservice. Because in addition to the image jump, which is annoying, we're maximizing image displacement because we're adding a base down prism to a base down prism. The appropriate bifocal segment for this patient is going to be a flat top, because the flat top is going to be a base up prism that we're adding to the patient's own base down prism that's at the bottom of his distance spectacles, which will minimize image displacement. And as an extra added bonus benefit, this type of bifocal also is going to have much less image jump. And again, to reinforce this point, I think for the last time, the reduced image jump is an added benefit, but it is not the criterion that we are going to use to decide which sort of bifocal add we are going to prescribe.